Welcome to the Keys and Cryptographic Algorithms lesson. Click Next to get started. After completing this lesson, you'll be able to achieve these objectives. Describe a digital key and how it's used. Explain what key stretching is. Describe the difference between symmetric and asymmetric algorithms. List common symmetric and asymmetric algorithms. Describe the encryption process using symmetric and asymmetric cryptography. What is a digital key? In cryptography, a digital key is a value, which can be expressed alphanumerically, that's used to perform cryptographic operations. The types of things that digital keys can be used for include digital signature, message authentication code, MAC, and encryption. With respect to encryption, keys can be used to encipher the flow of information between two devices, bulk stationary data, or a small piece of data, such as another digital key or hash output value. Depending on the task that the key is performing, its lifetime could be years or a few seconds. For example, a key used to sign certificates might be valid for 10 or more years, but a key used to encrypt a session between two devices is only used for the duration of that session. Keys are usually kept private or secret, but they can also be public. Public keys are often written to digital certificates. Click the underlined term for more information. Public keys are often 1024 bits or 2048 bits or larger. Because of their relatively large size, public keys are often used to encrypt small pieces of data, like another key or a hash of data. To encrypt large amounts of data would take too long. Smaller keys in the 128-bit to 256-bit range are used to encrypt bulk data. So the type or size of the key that is used is determined by the type of cryptographic operation being performed. If you're encrypting a key to safely transfer it to another entity, then use a larger key. If you're encrypting a stream of data where performance is critical, use a smaller key. While this rule of thumb is applied for performance reasons, there are also security issues to consider. The length of the keys impacts its strength, but the length is not the only factor to consider when calculating key strength. The complexity of the key is also an important factor. Consider a password that is 10 characters long, but all 10 characters are digits. A 10-digit password has 10 billion possible permutations. In contrast, an 8-digit character password that combines digits plus upper and lower letters has over 218 trillion permutations. Although 2 characters less in length, the latter password is much stronger than the former. Key stretching is a method used to strengthen keys or passwords that are either too short or predictable. The process involves feeding the key or password into a hashing algorithm to produce an enhanced key or password. Examples of stretching algorithms are password-based key derivation function 2, PBKDF2, and bcrypt. Bcrypt is the default algorithm used for stretching in OpenBSD and various Linux distributions. When bcrypt is used, a key or password is hashed multiple times before a 128-bit salt is added. Then the combined value is hashed once more. The final hash output is the enhanced key or password. A salt is a random value added that is added to another value to increase entropy. What is symmetric algorithm? A symmetric algorithm is a cipher used to encrypt and decrypt data using the same key. Examples of symmetric algorithms are Data Encryption Standard, DES, Triple DES, International Data Encryption Algorithm, IDEA, Advanced Encryption Standard, AES, Rivas Cipher 4, 5, and 6, and Blowfish and Twofish. With the exception of RC4, which is a stream cipher, the rest are block ciphers. Click each algorithm type to learn more. The main advantage of symmetric cryptography is that it can encrypt and decrypt data more quickly than asymmetric cryptography. This is because symmetric keys are shorter than asymmetric keys, and symmetric cryptography uses the same key to encrypt and decrypt. Symmetric cryptography works in a way that's similar to a combination lock. Imagine that Frank, Javier, and Nora all work in the same facility and all need a key to access a secure room. They all work different shifts, and the employer does not allow the key to leave the building. The employer secures the key in a lockbox with a combination code. Frank, Joe, and Nora all need the combination code to access the key and to secure the key. However, this similarity to a combination lock exposes one disadvantage of symmetric cryptography. Because you use the same key to encrypt the plaintext as you use to decrypt the ciphertext, the key must remain a secret to protect the data. How do you protect the secret key? If Alice encrypted a message for Bob, she could safely send the ciphertext. But how would she securely deliver the key? How does symmetric cryptography work? To encrypt information using symmetric cryptography, a crypto application uses a symmetric key and cipher to convert the plain text into ciphertext. In order to decrypt the ciphertext, the same symmetric key and cipher convert the ciphertext to plaintext. But the problem remains, how do you securely send the key to the receiving party? What is an asymmetric algorithm? An asymmetric algorithm is a cipher used for cryptographic operations using a pair of mathematically related keys. They can do all or some of these operations: encryption, key exchange, digital signature. A key exchange operation enables two parties to safely exchange a secret or key over a public channel, such as the internet. Asymmetric algorithms and cryptography are also known as public key algorithms and cryptography. Examples of asymmetric algorithms are Diffie-Hellman, Rivest, Shamir, and Edelman, RSA, elliptic curve cryptography, ECC, pretty good privacy, PGP, and GNU Privacy Guard, GPG, and digital signing algorithm, DSA. Click each algorithm to learn more. Increased data security is the primary benefit of asymmetric cryptography. This is because users are never required to share their private keys. Asymmetric cryptography employs a pair of mathematically related keys. For encryption, the public key encrypts and the private key decrypts. Asymmetric cryptography is similar to a locking key. The lock secures the item and only the correct key can unlock the lock. The principal disadvantage of asymmetric cryptography is that the crypto processes are very slow compared to symmetric cryptography. This becomes a problem when you're streaming encrypted data between 2 points, or when you need to encrypt and decrypt large amounts of data. The slowness of asymmetric cryptography does not make it viable in these circumstances. How does asymmetric cryptography work? During the encryption process, the sender's crypto application converts the plaintext data into ciphertext using the recipient's asymmetric public key and asymmetric cipher. During the decryption process, the recipient's crypto application converts the ciphertext to plaintext using their private decryption key and the same asymmetric cipher that the sender used. The main disadvantage of symmetric encryption is securely delivering the key to the recipient. while the main disadvantage of asymmetric encryption is its slowness. When symmetric and asymmetric cryptography are combined, the disadvantages of both are remedied. Symmetric encryption uses bulk data to ensure good performance, while the symmetric key, a small piece of data, is encrypted by the recipient's public asymmetric key. Thus the question, how do we securely send the key to the receiving party, is answered. In a scenario where the processes are combined, Alice sends an encrypted message to Bob. In the first step of encryption, Alice's crypto application generates a one-time symmetric key, and together with symmetric algorithm, encrypts the message. In the second step, the application retrieves Bob's public encryption key and uses this key, together with an asymmetric algorithm, to encrypt the symmetric key. In step 3, the encrypted message and key are sent to Bob. In the first step of decryption, Bob's crypto application retrieves the private key from its secure key store. At this stage, Bob may be required to submit credentials. The private decryption key, together with the same asymmetric algorithm that Alice used, decrypts the symmetric key. In the second step, the symmetric key together with the same symmetric algorithm that Alice used are used to decrypt the bulk data. You've completed the lesson. You can now achieve these objectives. Describe a digital key and how it is used. Explain what key stretching is. Describe the difference between symmetric and asymmetric algorithms. List common symmetric and asymmetric algorithms. Describe the encryption process using symmetric and asymmetric cryptography.